Cal, today we are going to start talking about lines in the coordinate plane and some of the characteristics of those lines. And the first characteristic is perhaps one of the most important characteristics, and that's called slope. Slope is, in another word, or in a simpler term, is how slanted the line is. Another word we might use is how steep is the line. Slope for lines is very similar to when we talk about the slope of a hill, the slope of a ramp, the slope of the road. It's how steep that road is, up or down. So we can find the slope of a line in a few different ways. One way would be if we were actually given the graph of that line. And so in these lines that I have pictured, we have some points that are called out on those lines. These lines contain an infinite number of points, an uncountable number of points. These ones that we've made big in blue are just examples of a couple points on those lines. So if I look at this first point, it has an X and a Y coordinate. The X tells us how far to the left or right the point is from our origin, that point in the middle, if you remember that. X is our first number. So this red point on the left is 4 units to the left of our origin, and that means it's -4. The second number in our coordinate is the Y value. The Y value tells us how far up or down we go from the origin. Well, if we're starting at that purple point in the middle to get to my red point on the left, I don't have to go up or down at all, so our Y value is 0. If I look at my orange point, my first value is my X. It's how far to the right I have to go or left from my purple point. I go to the right 1, 2, 3 spaces. So my X value is 3. My Y value is how far did I go down? I went down 3. Down is negative. My Y value is -3. That's just a quick recap on finding coordinates. And that's what those coordinates mean. It's a location in the coordinate plane. Well, we can use these two coordinates to decide how slanted or how sloped this line is. Whenever we have a line that goes down to the right, so as I read from left to right, my line here is going down. It's going to have a negative slope. And so when we report a number that tells us our slope, it should be negative. We have lots of different formulas for slope. One that we can use here is the change in Y over, as a fraction, the change in X. The letter we use to represent slope is lowercase m. So in order to find the change in Y, what I would like to do is I would like to find, if now I start at my red point and I go to my orange point, how far up or down do I have to go? Let's not confuse this with finding coordinates. When we're finding coordinates, we find out how far do we have to go up or down, how far do we have to go left or right from the origin, that purple point that I put there. When I'm finding slope and I'm finding change in Y, it's similar. I want to know now, if I pick 2 points on my line, how far do I have to go up or down to get from one point to the other? So to get from my red point, I have to go down 3 in order to move right to get to my orange point. Down in the coordinate plane is negative. My change in X is how far to the right or left do I have to move now to get to that next point. So I've had to move down 3 to get from the red, and now I have to move over 1, 2, 3, 4, 5, 6, 7. In the coordinate plane, right is positive, so +7. This fraction tells me my slope. What this tells me is that if I start at any point on my line and I go down 3 and right 4, I'm going to be back on the line at another point. That is my slope. And that is what slope tells us. It tells us how we can move from one point to the next on a line. So in the coordinate plane, I don't have to actually find the coordinates to get the slope. I just wanted to point out what those represented. So if I'm looking for the slope of this line, well, this line, as I look at it from left to right, goes up. This is a positive slope. So my final fraction should be positive. You can see over here, my final fraction was negative 3/7. So if I'm starting from my point on the left, and I always start on the left, if I'm starting from my point on the left to get to my point to the right, I have to go up 2. Up is positive, so my top number is positive. Then I have to go right 2. Right is positive, so that bottom number is positive. It's not a bad idea to every time you try to find the slope, you write the relationship here that slope is change in y over change in x. The biggest mistake people make is they flip those. The more you write that, the better you'll remember it. So here I have a slope of 2/2. I want to always simplify my slope. If I can, the fraction. Negative 3/7 doesn't simplify, but 2/2 does simplify to 1. My slope is 1. That means every time I go up 1 to the right 1, I'm back on my line. Up 1 to the right 1 on my line. Up 1 to the right 1. Forever and ever and ever. If I go up 1 space to the right 1 space, I'll be back on my line. We're not always given the picture of a line, but if we have the coordinates of 2 points on that line, we can also find the slope. Remember that our first numbers in a coordinate are x's, the second numbers in a coordinate are y's. My formula is still the same, or my relationship, the change in y over the change in x. We're going to have to do a little subtracting here. Change means subtracting. When I pay for something at the store and they give me change, the way they figure out how much I get back is by subtracting what I owe from what I gave them. And so if we want to find the change in y, we are going to subtract the y's. So another way you can think about it is we need to subtract. We're going to subtract the y's, subtract the x's. That's a little bit longer. We can just say change in y over change in x. If I have my points written the way they are, I usually just like to take my y on the left and put that first, negative 17, subtract, minus, positive 7. Then I'll take my x on the left, negative 9, subtract 2. It's a good idea to label them as x and y so that when you are putting them into your subtraction, you know which numbers to pick. So on the top are my y's, negative 17 and negative 7. On the bottom are my x's, negative 9 and positive 2. And then I can do this subtraction. Negative 17 minus 7 is negative 24. Negative 9 minus 2 is negative 11. We should always pop this into Desmos to see if we can simplify it. This does not simplify, but what does happen is these two minus signs make this a positive final answer of 24/11. So it's always a good idea to pop the fraction into Desmos and see if you can simplify it. And what it will do for you is actually show you that our answer is positive. So this line would be going up to the right. I'm going to do the same thing over here. We should always write the relationship. The more you write it, the more you'll remember it. That y is on top. You should label these as x and y. And then I just typically, like I do when I look at the graph, I like to go from left to right. So my first y is 16, subtract My second y is 8. First x is negative 13. Subtract. Second x is 17. If you struggle with adding, subtracting positive negatives, that's okay. Just know that and use Desmos to help you. 16 minus 8 is 8. Negative 13 minus 17 is negative 30. We can simplify this to negative 4 over 15. So that line will go down to the right. It has a negative slope. One last way we can be presented information about lines is through a table. In our tables, the left number is an x and the right number is a y. And so that creates coordinates x, y, x, y, x, y. And so actually we have 4 points that are going to be on this line that's relating balloons and how much they cost. And so we can use this just like we did on the last couple questions where we had coordinates. And so I'm just going to take my change in y over change in x. I'm going to pick 2 points. You could pick any two. I'll just pick the first two. And I'll take my first y, 6, and subtract 12. My first x2, subtract 4. I'm going to get on top negative 6 and on the bottom negative 2. And if I pop that into Desmos, it's going to tell me it is positive 3. And we could actually write that as 3 over 1. So what we know, our slope means to go up 3 to the right 1. Same thing in this one. X is on the left, Y is on the right. You can pick any two coordinates. I'll pick these last two just to show you that it works. My change in Y, I'm going to take my first Y4, subtract my second Y5. Then take my first X8, subtract my second X10. I get negative 1 on top and negative 2 on the bottom. Pop that into Desmos. The fraction doesn't simplify, but that negative 1 and negative 2 make positive 1/2. That means my line goes up 1 to the right 2. So if I were to graph the coordinates in Desmos and try to put a line through there, it would go up 1 to the right 2 and be at another point. We do have some special cases of lines that are horizontal. That means they go from left to right. It's possible that when we are finding a slope, we get the answer of 0. If we get 0 on top of a fraction, like this, that always simplifies to 0. And you would know that if you pop that in your calculator. 0 divided by 2 is 0. That represents the slope of a horizontal line. Anytime we have a line that goes straight from left to right, the slope will always be 0. So if we see a line like this in the coordinate plane, its slope will be 0. If we are doing some calculating from coordinates or a table, and we see that our final answer is 0, that doesn't mean we're wrong. That means we have a horizontal line. When we have a line that goes straight up and down, we call that vertical. When we have that sort of line, that means when we are solving for slope, we will have 0 in the denominator. We'll have 0 on the bottom of the fraction. If we put that into a calculator, it will tell us something like error, or it will tell us, UND or undefined. If we have a vertical line like this, the slope we say is undefined. If we're calculating using coordinates, we'll end up getting something where there's a 0 on the bottom of the fraction, and our calculator will tell us one of these things. Either there's an error or it's undefined. That's because we have a vertical line, and that means that our slope is undefined. That's might be a little bit new. It might sound a little bit tricky. Anytime we have a line that goes straight up and down, it has an undefined slope. So here's what I want you to do. I want you to pause here, and I want you to find the slope in each of these situations, one with a graph, one with coordinates, and one with a table. So please do pause here, find these 3 slopes, and then press play, and I'll have the answers. So go ahead and check your answers. They all happen to be D. If you got one or more of them wrong, please do immediately raise your hand and let's chat about maybe if you switch the X's and Y's, or maybe you just made a subtraction error, or maybe sometimes you just count wrong on the graphs. That's been known to happen. Simple mistakes to fix, but please do raise your hand so we can try and find those mistakes and fix them before you go on to the practice. When you've got your questions answered and you're ready, please do go do the practice. There are 20 of them. Take your time on them, and good luck.